Welcome to SSR Pharma Media, your trusted source for pharma knowledge, Pharmaceutical Inorganic Chemistry and Pharmaceutical Analysis. That we are going to discuss about gravimetry. Prepare, practice, succeed. Your exam power boost. So, under the gravimetry topic, we are going to cover gravimetric analysis and principle, types of gravimetric methods and examples, steps involved in gravimetric method, factors to consider during preparation of the sample solution, impurities in gravimetric precipitations, von Wiener theory interpretation, estimation of barium sulfate by gravimetry. So in that, gravimetry means, gravi means weighing, metric means measure. So weighing the measurement of weight. So it is called gravimetry. Measurement of weight is called gravimetry. Gravimetry is a chemical analysis based on weight measurement. Gravimetry is a branch of analytical chemistry used to determine the quantity of a substance by measuring its mass. Gravimetry is best defined as, so option B is answer, a technique used to determine the quantity of substance by measuring its mass. And types of gravimetric methods and examples. So precipitation gravimetry, volatilization gravimetry, electrogravimetry, thermogravimetric analysis, direct weighing of solids. So these are all the methods of types of gravimetry. And precipitation gravimetric, the principle is analyte is converted to low solubility solid precipitate, which is filtered, dried and ignited and weighed. And volatilization, analytes or its decomposition products are volatilized and mass loss or gas produced is measured. Electrogravimetry is analyte is deposit on an electrode by electric current and weighed. Thermogravimetric analysis, continuous measurement of mass change with temperature. And direct weighing of solids principle, solids are separated physically and weighed. So these are all the examples of the concerned types of gravimetry. Determination of chloride by precipitation as silver chloride is an example. Option C is answer, precipitation gravimetry. So chloride ions reacts with the silver ion to form sparingly soluble silver chloride, which is filtered, dried and weighed, typically of precipitation gravimetry. Determination of moisture content in a sample by heating and measuring weight loss is, so option B, volatilization gravimetry. Continuous measurement of sample mass as the temperature increases is characteristic of, so option A, thermogravimetric analysis. Deposition of copper metal on a platinum electrode during analysis is an example of electrogravimetry. Option B, electrogravimetry. Determination of sulfate ion by converting them into barium sulfate belongs to, so option C, precipitation gravimetry. Measuring suspended solids by collecting them on filter paper and weighing is, so option B, direct gravimetric method. So next we will see the gravimetric steps involved in gravimetric methods. So already told, gravimetry means measurement in weight. So it is the gravimetry. So here steps involved in gravimetries are very important. Preparation of solution is the first step. Second step, precipitation formation. Third step, digestion. It is type of Oswald ripening. Fourth step, filtration and weighing. Fifth step, drying and ignition. And next step, weighing. And last step is calculations. So these are all the steps involved in the gravimetric method. In the preparation of the sample, The sample is dissolved and pH is adjusted and interfering ions are removed. So that is the first step involved in the preparation of the solution. The solid samples are dissolved in suitable solvent and pH is adjusted, then interfering ions are removed. Then precipitation. So by adding the precipitating reagent slowly with stirring. This is second step. And conditions are controlled to favor formation of large and pure crystals. Here only the crystal formation takes place during precipitation step by adding the precipitation reagent. And digestion. So digestion is also called as Oswald ripening. The warm precipitate in solution to remove purity and crystal size. So in this digestion is a warm precipitate in solution. So third step is digestion. This step is the digestion. So in the digestion step, the crystals, the precipitation formed in this precipitation step, allowing the precipitate stand along with the mother liquid. So mother liquid means then we'll sample we will dissolve and we'll add the precipitating reagent. So that solutions will be there. That solutions are considered as a mother liquid. So the formed crystals are the precipitates allowed to stand for overnight or 24 hours in that mother liquid. Then only the warm precipitate in solution to improve purity and crystal size will increase the crystal size so that it's a reduce the impurity. So improve the purity. So this is called Oswald ripening or digestion. So digestion means so allowing the precipitate to stand along with the mother liquid for long 24 hours or overnight. So after the formation of large crystals, next we will go for the filtration and washing. So filtrations and washing, use filter paper or Gooch crucible. Then wash with a suitable electrolyte solution to remove adsorbed impurities. Adsorbed means so the along with the particle crystals, there may be the impurity may adsorb stick on the crystals. So that adsorbed impurities are removed by washing with electrolyte solutions. So next drying and ignition. So heat to constant weight, then convert the precipitate to a stable form. So it is called drying or ignition. And weighing, weigh the dried or ignited precipitate accurately. And finally calculation, use stoichiometry to compute percentage purity or amount of analyte. So this is a digestion step. So after the digestion filtration takes place, so then is a washing and drying. And drying we use the muffle furnace. So muffle furnace, then finally calculations. So these are all the steps involved in the gravimetric analysis. So next is a digestion of precipitate is a very important. Digestion is a process keeping the precipitate within the mother liquid. So solutions from which it's precipitate for certain period of time to encourage a desintegration of nuclei. Next, during digestion, small particles dissolve and large one grows. It is called Oswald ripening. So small particles so dissolve and small particles aggregate together and form so large crystals. So it is called Oswald ripening. So this process helps reduce large crystals that are more easily filtered from the solutions. So Oswald ripening improve the purity and crystallinity of the precipitate. So Oswald ripening, this is a small crystals called nuclei. So small crystals are joined or aggregate together and forms a large crystal so that the adsorbed impurities are reduced. So next is the factors to consider during precipitation of the sample solution. So factors, complete dissolution. So it is important to ensure full availability of analyte. Removal of interference to avoid erroneous precipitate. pH control determines solubility and selectivity. Temperature, it is enhanced the crystallinity and purity. Ionic strength, reduced colloid formation. Dilutions, colloidal supersaturation. Controls colloidal supersaturation. Masking agent, prevents side reactions. Reagent purity and slow addition, improve impurities. Prevent impurities. Oxidation state, ensures correct chemical form. Clean apparatus, prevent contaminations. And factors to consider during preparation of the sample solution. Without complete dissolution, some analytes stay undissolved, so leads to low results. Masking agent or selective precipitant removes ions that form unwanted precipitate. Any ion precipitate only in specific pH ranges. Wrong pH may inhibit or contaminate precipitate. High temperature decreases supersaturation, large pure crystals and fewer impurities. Electrolyte compresses the double layer, so particle aggregates into large crystals. So, slow addition avoids sudden supersaturation to better crystal growth. Dilution reduces, so favoring crystalline and precipitates over colloids. Wrong pH can precipitate hydroxide or other undecided species. Interfering ion form their own precipitate, produce falsely high mass. So may precipitate form only from a specific oxidation state. Next, factors to be considered during sample preparation. So main thing is the pH. So pH influences the solubility of the analyte precipitate, possibility of interferences from the other substance. For example, during calcium oxalate precipitation, calcium oxalate precipitate insoluble in basic medium but soluble in acidic medium. So it is a soluble in acidic medium, so insoluble in basic medium. So reason in acidic is a low pH medium, oxalate ion react with hydrogen ion to form weak acids, which is soluble. And at low pH, so oxalate ion combines with the hydrogen ion to form a weak acid. So it is a insoluble. This is insoluble. It is a soluble. Factors to consider during sample. Second example, 8-hydroxyquinoline precipitating agent used as a precipitating agent. So 8-hydroxyquinoline is oxime is used to precipitate a large number of elements, and precipitation occurs selectively and is controlled by pH. So an aluminum ion can be easily precipitated at pH 4. Magnesium ions are concentration of anion form of oxime is too low at pH 4 to precipitate magnesium ion. Higher pH is required to shift ionization and precipitate magnesium. If pH is too high, magnesium hydroxide will precipitate, causing interferences. So reactions. During calcium oxalate precipitate, the precipitate dissolves in which type of medium? So option B is acidic medium. Why does magnesium not precipitate with 8-hydroxyquinoline oxime at pH 4? So option B is the answer. The anion form of oxime is too low at pH 4. Interfering ions in a sample solution are usually removed by, so option B, masking or pre-precipitation. pH adjustment during sample preparation is important because it, so option A, affects solubility of the analyte. Precipitation carried out at higher temperature generally results in, so option C, better solubility of impurities and larger crystals. Which factor reduces colloid formation and helps form? Which factor reduces colloid formation and helps form easily filterable crystals? So option B, presence of electrolytes. Why should the precipitating agent reagent be added slowly during sample preparation. So option B, to promotes formation of large and pure crystals. Using dilute solutions during precipitation mainly helps in, so option B, decreasing the relative supersaturation. Maintaining electrolytes in the correct oxidation state during sample preparation is important because, so option B, only specific oxidation state form the intended precipitate. Oswald ripening refers to, so option B, growth of large crystals at the expense of smaller expansion of smaller ones. Oswald ripening occurs because, option C, smaller particles have higher solubility. So next is impurities in gravimetric preparation. This is a very important topic. So the types of impurities are adsorption, occlusion, inclusion, mechanical entrapment, post-precipitation and co-precipitation. So these are all the very important impurities occurs during gravimetric precipitation. So an adsorption means it is occurs due to surface accumulation. So if the crystals are there means, so above the crystals, so the impurities may adsorb on the surface of the crystal. So this is called adsorption. When number of particles are more, so more number of surface area produced. So more number of impurities may adsorb. If particles, number of particles are less, that means large particles. If it is there, the number of particles will be less. So in that case, so less number of surface area. So the number of impurities may reduced. So larger particles, less number of surface area, so impurities are less. Smaller particles, more number of surface area, so the impurities are more. And it is prevented by, this adsorptions are prevented by using digestion, washing with electrolytes. And occlusion means trapped during crystal growth. The impurities are trapped inside the crystals during the crystal growth. So it is formed due to it is prevented by slow precipitation formation. Inclusion is ionic substitutions. So it is prevented by remove interfering ions. And mechanical entrapment, liquids, that means water or any liquids trapped in aggregates. So it is trapped by the crystals. So it is prevented by proper stirring and washing. And co-precipitation. So co-precipitation means, so we need to precipitate post-precipitation. Post-precipitation means second precipitate former later, and it is prevented by immediate filtrations. Co-precipitation means combination of the above. So combination of the above means, so if we want to precipitate one ion, so along with the calcium, suppose phosphate is there, first calcium and phosphate both get precipitated. So this is called co-precipitation. So post-precipitation means, first we want calcium ion will precipitate, later on phosphate ion will precipitate. So it is called post-precipitation. So occlusions and inclusions. Occlusions means trapping of impurity within the crystals. So example, water may entrap in pockets when silver nitrate crystals are formed. So it's a water is entrapped in occlusions. So in the silver nitrate crystals, it is type of impurity. Inclusions means trapping of impurities within the crystal lattice. Example, potassium ions. Oh, so it is this water molecule between the crystals, but inclusion means inside the crystals. So individual crystals it may adsorb. To minimize adsorption impurities, the most effective step is, so option C, digestion of precipitate. Inclusions occurs when, so option A, ion substitute a smaller size ion in the crystal lattice. Which impurity is most likely when precipitation is done rapidly with high reagent concentration? So option C, occlusion. So which one is an example of surface impurity rather than lattice impurities? So option C, adsorption. To minimize adsorption impurities, the most effective step is, so option C, digestion of precipitate. Post precipitation occurs when, so option B, second precipitation form after the main precipitate has settled. Mechanical entrapment of impurities mainly results from, so option C, poor washing of aggregates. Which impurities type is least likely to be removed by washing? So option B, occlusion. So next is a von Wiener theory. It's mainly used in the gravimetry. Von Wiener theory explains how supersaturation affects the size, purity, and quality of the precipitate formed during gravimetric analysis. So the degree of supersaturation controls the type of precipitate formed. So relative supersaturation is equal to Q minus S divided by S, where S is the concentration of solute at the moment of the precipitation. S is the equilibrium solubility of the solute. So why von Wiener theory is important? Means it helps predict the precipitate quality and it guides how to minimize impurities and it ensure accurate gravimetric results. So used in design precipitation conditions for analytical chemistry. And in von Wiener theory, it is used the high supersaturation to colloidal precipitate. It leads colloidal precipitate, and low supersaturation leads crystalline precipitate. So we require only low supersaturation. We does not require high supersaturation. If high supersaturation takes place, fast precipitation may occur and formation of very smaller particles. Already I told very smaller particles means more number of particles may form. More number of particles, it increases the more number of surface area. So it is increases the more number of impurities. So high tendency for adsorption, occlusions of impurities. Difficult to filter. For example, gelatinous substance of ferric hydroxide and aluminum hydroxide. So here precipitation, crystalline precipitation means, so slowly precipitate form, controlled precipitation, formation of large and pure crystals. So large crystals means number of surface area less and impurities are very low. So easy filtrations, fewer impurities. So here it is occurs, the high supersaturation occurs when reagent added quickly, high reagent concentrations and low temperatures and poor mixing control. So due to these reasons, high supersaturation may occur. So in low supersaturation is achieved by slow addition of reagent and use dilute solution precipitating agent and elevated temperatures mean low temperature and good stirring and proper digestion. It leads proper oswald ripening. Supersaturation although high colloidal particles are formed and smaller impurities difficult to filter. So decide no. So low supersaturation crystalline particles are formed, large, pure and easy to filter. Yes. According to the von Wiener theory, a high degree of supersaturation during precipitation leads to formation of, so option B, colloidal precipitate. Which of the following conditions helps achieve low supersaturation and thereby form good crystalline precipitate? So option B, slow addition of dilute reagent. According to von Wiener, for the best gravimetric precipitation, the relative supersaturation should be option B, moderate to low. According to the equation for relative supersaturation, which of the following changes will increases the relative supersaturation value? So option C, increasing Q while keeping S constant. So if if the concentration of solute at the moment of precipitation is only slightly greater than its equilibrium solubility, what type of precipitate will most likely form? So option B, large crystalline precipitate form. Which conditions will most likely produce a colloidal precipitate during precipitation reaction? So option B, high relative supersaturation. This leads very fine particles. Relative supersaturation determines the types of precipitate formed during a precipitation reactions. Which of the following correctly describes the impact of RSS on precipitate formation? So option C, low RSS favors formation of relative supersaturation. RSS means formation of large, well-defined crystals due to low nucleation. So nucleation means separation of the larger particles into smaller particles. It is called nucleation. So large one converted into smaller one. It is called nucleation process. So during nucleation, impurity may increases due to number of surface area may increases. So next is a principle involved in the estimation of barium sulfate precipitate. So barium ions are quantitatively precipitated as barium sulfate by adding sulfate source as a precipitating reagent. So barium sulfate is highly insoluble, it is stable and easily filterable. It is a type of crystalline particles, hence suitable for gravimetric determination. So barium ion react with the sulfate ion to form barium sulfate crystals. It is the procedure preparation of the sample. So by dissolving in the water. Next is the precipitation by adding the sulfuric acid as a precipitating reagent, and next is the filtration step and drying and ignition. So by following these procedure, we will estimate the barium as a barium sulfate precipitate. Says and calculation finally. So calculation weight of the crucible plus barium sulfate. So if you substitute this in this your formula, you will get the purity of the barium as a barium sulfate. So you take a screenshot and read this formula. V1, W1, W2 and W1 minus W2. These are empty crucible. W1 means is a barium sulfate plus empty crucible. W2 means empty crucible. So difference between these two leads only barium sulfate precipitate. So by the barium sulfate, it's a molecular weight of the barium sulfate and barium is a molecular weight. In substituting this formula, you will get the purity of the barium sulfate in barium in barium sulfate precipitate. Precipitating reagent used for conversion of barium into barium sulfate is option B, sulfuric acid. Barium sulfate is a suitable gravimetric precipitate because it is, so option D, sparingly soluble and stable. During estimation of barium sulfate, digestion helps in, so option C, improving crystal size and purity. Which of the following filter type is most commonly used in gravimetric analysis requiring ignition? So option C, ashless filter paper. To avoid peptidization of barium sulfate precipitate, washing is done with, so answer in the comment box. So thank you. Join in our WhatsApp community. We will get hands out material. Thank you. Like, subscribe and share.